So look at this. I'll follow in this manner. They all meet over here. So one leg, this line here, and then this line over here. So it means AB is holding angle O, or is subtending angle O. Or somebody will also say angle O is standing on line AB or chord AB. So if you check the angle O, one leg here, the other leg over here. So that is the meaning of the word subtend. So subtend means it is holding the angle. And when it is holding the angle, the legs of the angle or the lines which creates the angle should have a connection with the chord. It should have a connection with the chord. It should stand on the chord. So for the last time, we have AB here. We say AB is a chord, and it is subtending the angle O because if I trace the chord AB, the angle O is standing on the AB because one leg of O is at A and the other leg of O is at B. And you realize that this O is at the center of the circle. O is at the center of the circle. So I will say chord AB subtends angle O at the center. So let's write that. Chord AB subtends angle, we don't say angle O, somebody will say angle AOB, somebody will say angle BOA, or simple angle O. It is all accepted. So the chord AB subtends angle AOB at the center. Now, if you don't write chord and you write line, it is accepted because this is a straight line. So if you say line AB subtends angle AOB at the center, it is also accepted. If you don't use chord and you use line, it is accepted. So it says line AB subtends angle O at the center. Line AB subtends angle O at the center. Now, as I said, you can also turn it and say the angle O is also standing on the line AB or the chord AB. So if you don't want to use the word subtend and you want to use the word stand, you can also say angle O stands on the line AB or is standing on the line AB. So angle AOB stands on the line. Stands on the line AB. So that is the meaning of the word subtend. Holding or standing on. All right. Now, let me do a little demonstration before I go to angle subtended at the circumference. Now, tell me the name for the line OA. The name for the line OA. I gave you the name for the line OA in your definitions. So in 30 seconds, tell me the name of the line OA. Good. I know some will get it, others will also not get it. But as we move on and explain more, you are going to get it. So you realize we said OA here is a radius, because the radius is a straight line from the center to a point on the circumference. So look at the line O, the point O, and the point A. So the distance from O to A, that is the radius. A straight line from the center to the circumference. So who can tell me the name for the line OB? Line OB. the name for the line OB. So you realize OB is also a radius. So this is radius, and this here is also a radius. Now you remember from our definition, we said that the radius is equidistance. It is of equal distance from a fixed point. So the radius we use in drawing this circle is always equal or the same. So if the radius, the distance from O to A is 5 centimeters, then it means that the difference from O to B will also be 5. So it means the radius will always be equal in length. Because the radius is equidistance. We explained that, equidistance. So you realize that the line OA here is equal to the line OB. So line OA and OB are equal. Now I put the same number of strokes on the line to show that they are equal. If I use 2 strokes, you have to use 2 here. So if I make this 2, then this one also must be 2. To indicate that this length and this length are equal. If this length and this length are equal, then what it means is that triangle ABO becomes an isosceles triangle. And I hope most of you have not forgotten about what we taught you under plane geometry. We explained that whenever you have a triangle with 2 lengths being equal, that triangle is an isosceles triangle. So triangle OAB here becomes isosceles. Please follow attentively, because these are the things we'll be using to answer the questions. If you don't bring your attention in class to get these things, then you should know that circle theorem, you will not get a picture as we move on. So I have given you time. I'm taking them one after the other. Please follow. Don't lose concentration. Follow. Okay. So that makes triangle OAB isosceles. And we explained that it becomes isosceles because you have 2 radii. We have OA and OB. And because radius is always equal in length, the length here and the length here will be the same. So if these 2 lengths are equal, then this triangle will become isosceles. For isosceles triangles, the base angles are also equal. We learned on that. Base angles are equal. So because this length is equal to this length, then it means that the angle here and the angle here will also be the same. So assuming this angle is x, then it means this angle here will also be x. Now let's look at angle subtended at the circumference. So we've seen angle subtended at the center. So angle subtended at the center. Now let's look at angle subtended at the circumference. Let me call the center O. Now, if you can remember, tell me, what did I say we use to subtend angles in a circle? I mentioned two tools that we use to subtend an angle in a circle. Good. So I said we use arcs and chords to subtend angles. So over here we are coming to look at angle subtended at the circumference. And I also explained that I'm only going to use the chords for now. I'm going to use only the chords to subtend angles. So let me once again draw a chord into this diagram. Let me introduce a chord. Let me call this chord CD. CD. CD is a chord because it joins the point C to the point D. Now remember, we said the circumference is the whole boundary here, the edge of the circle, the roundabout, the thick roundabout. You see, that is the circumference of the circle. So I need this chord here to subtend. Remember, I said subtending means that the angle is standing on the chord, or the chord is holding the angle. Any of them is accepted. Either you say the angle is standing on the chord, or the chord is holding the angle. So for the chord to subtend an angle, then the angle must have a connection with the chord. It must stand on it. So look at what I'll do. Now we have triangle BCD. Now we said CD here is a chord. Now let's look at the angle that CD is subtending. If CD is subtending an angle, the legs of the angle should stand on the chord CD. So look at CD. Let's look at the angle that is standing on CD. So I will trace the legs of the angle. I'll be tracing the leg. So it means CD here is subtending angle B. CD is subtending angle B. It is subtending angle B because angle B is standing on CD. And how do I know that? If I'm following the lines which creates the angle B, I have this line. So realize that this line ends on the point C. So it has a connection with C. And then if I trace this line, it is standing at a point D, or it ends at a point D. So the angle B here is standing on CD. These two lines here will create the angle at B. So the angle B is standing on the line CD. And we know that because of the lines creating the angle B, or the legs of angle B. Angle B has one leg at C and the other leg at D. So CD here is holding angle B, or is subtending angle B. We can also say angle B is standing on the line CD. Angle B is standing on the line CD. So CD here is subtending angle B. So I told you can say line CD, or you can still use the word chord. So chord CD subtends. Oh, why am I using capital letters? Chord CD subtends angle DBC. chord CD subtends angle DVC, meaning angle DVC is standing on chord CD. So we can use that as an alternative way of writing it. You can also say angle BCD stands on the chord CD. After, if you don't use chord, you can use line. You can say line CD, which is also accepted. Which is also accepted. Now let me introduce another thing here. Now let's look at the name given to the line CD. Look at the line CD and tell me the name for the line CD. CB, sorry. CB, as in boy. CB. The name for the line CB. Point C, point B. So, if you were able to grasp what we explained earlier on, you realize that CB here is called a chord. Why is it a chord? We have one point here, point C. We have one point here, point B. The straight line which joins 2 points on the circumference of a circle is a chord. So CB here is also a chord. And from the little explanation here, I told you we can always use chords to subtend angles. We use chords and arc, but I want to use only the chord. So you realize the chord, we use it to subtend angle. So it means that CB here is also subtending an angle. Let's look at the angle that CB subtends. To know the angle that CB subtends, we'll look at the angle that have a connection with the line CD. The angle that has a connection with the line CD. So this is my line CB. I will follow the lines which have a connection with CB. So you realize that this line and this line have a connection with the line CD. So I'll start tracing. So you realize that angle D is subtended by the chord or the line CB. How do I know that? Let's look at angle D. The angle D, the lines which create the angle D is this line and this line. Now this line here goes this way. It ends at a point C. This line also goes this way and it ends at B. So you realize that chord CB here is holding or subtending angle D. The legs of the angle D, or the lines which create the angle D, are standing. One has a connection with C, the other line has a connection with B. So the line CB or the chord CB is subtending the angle D. So let's write chord CB, chord CB subtends angle. We can go in the clockwise way or anti-clockwise. So B, D, C, or C, D, B. It is accepted. So subtends angle B, C, B, D, C. You can also turn it and say angle D is standing. Angle D is standing on the chord CB. So, or you can also say angle BDC is standing on the chord CB. Is standing on the chord CB. Now let's consider the last one. So we've seen this side, we've seen this side. Let's identify the name for the line BD. BD. The name for the line BD. BD is also a chord. BD is a chord. BD is a chord. Now let's look at the angle that BD is subtending. BD here, if it's subtending it, the lines creating the angle should have a connection with the angle. So you realize that angle C is standing on the chord BD. How do I know that? Now, if we consider angle C, the lines which creates angle C is this line and this line. Now, for this line and this line, the one line is going this way and it ends at a point B. The other line is going this way and it ends at the point D. So point D and point B here, which forms the chord DB. The chord DB here is subtending the angle C. So you realize for angle C, the legs of angle C have a connection with the line BD. So chord BD subtends angle C. Now you realize that all these angles that are being subtended, they are all at the circumference. They are all on the circumference. That is why we said angles subtended at the circumference. So if you look at the chord CD, the one we look at first, realize CD is subtending B and the B is at the circumference. We later looked at the chord CB. We said CB was subtending the angle D and D is at the circumference. Then we look at the last one, which is BD. BD is subtending